to get started here on our next Ivan workshop, NMRhub, cloud-based resources for NMR. At this time, I'll turn it over to David Rice.
Hello, welcome everyone. And I will, after that welcome, I'll turn things over to John.
Well, thank you, Dave, and good morning, everyone. Good afternoon, good evening, wherever you may be, and welcome to Ivan Workshop. Must be, Dave, what, 55 or so at this point?
It could be. I was about to say it, and then I realized I had forgotten, but it's up in there in the 50s. Higher than 55,
I guess what was sort of originally experiment several years ago at this point has really caught on. I guess we're doing something right. And once again, welcome everyone. Glad to bring you some very good material today. Very informative. A couple of very, very good speakers. MR Resources and Q1 Instruments are happy as always to sponsor the Ivan meetings. MR Resources, of course, in its fourth decade now, providing basically all the maintenance services, repair services that you could possibly need for the NMR system, quench recovery, system relocations, service contracts, full line of reconditioned spectrometers, of course. And last but not least, they have a fully equipped probe shop, can do virtually anything and everything in terms of repairs on both room temp probes, cryo probes, and cryo platforms, glass replacement, coil replacement, gradient replacement, probe tune-up, and the like. Please do get in touch with them for any of the requirements you might have. Also, Q1 Instruments, again, a proud sponsor of the Ivan Group. And we've got Don Bouchard with us today. Don, could I hand it over to you for a minute or so and maybe some words and updates on the Q1 line?
Thanks, John. We invite you to get to know Q1. Q1 is dedicated to developing NMR systems from 400 to 600, as well as full system upgrades from 300 to 600 as well. You can get a lot of features in a 2-channel NMR spectrometer at a great price. So we invite you to get to know more. Contact us at q1americas.com or info@q1americas.com by email. Thank you.
Thank you, Don. Very capable instrument lineup, and I'll dare say that stands up nose to nose with the other brands out there. Please do check them out. Next up, Krish, could I ask you to give us an update on meetings upcoming, please?
Thank you, John. Welcome, everyone. Next month, September 28th, that's the last Thursday of the month, as we typically do. We have a panel discussion on the topic of time domain NMR relaxometry. It will be led by Professor Mark Taraban at the University of Maryland, Baltimore. And you should be receiving invitations for registration on that shortly. And October, November, we have topics. We haven't nailed down the date yet, so we will announce that as they get solidified in place. With that, I think that's the 2023 lineup. I will pass it back to Dave.
Yeah. Okay, great. So our group leader, though he doesn't claim to be, is Jeff Hoke, and he's working with Mark, and he's going to be telling us about all the resources related to NMR box. So, Jeff?
Thank you, Dave. Thank you, everyone. It's great to see such a wonderful turnout. Again, as Dave says, I'm at UConn Health. Today, we're going to be describing 3 different resources that are free and available online under this umbrella organization called NMRhub.org. The person who's going to be doing the heavy lifting, describing the NMR box and NAN platforms, is Mark Macheski, who is Associate Director of the National Center for Biomolecular NMR Data Processing and Analysis, or otherwise known as NMR-Box. He's also Associate Director for the Network for Advanced NMR, which in contrast to the NIH-supported NMR-Box platform is a National Science Foundation project that is a collaboration among University of Connecticut, University of Wisconsin, and University of Georgia. Finally, at the very end, I will give you a brief tour of the Biological Magnetic Resonance Data Bank, which was founded at the University of Wisconsin back in the mid '80s by John Markley and Eldon Ulrich, but moved to UConn Health a couple of years ago. With that, I'm going to turn over the podium to Mark Macheski.
So today, as Jeff pointed out, I'm going to present the NMR-Box platform, and I'm going to present the Network for Advanced NMR, or NAN, at least where it stands today. Jeff sort of just gave the introduction to NMRhub. We started with NMR-Box 8 years ago or so, and when we did that, we had NMR-Box accounts. We've since added NAN, and more recently, and to accommodate, we didn't want to have yet another login for users, so we decided to create what we call NMRhub, which is sort of the single sign-on authentication across all our services. BMRB currently doesn't require authentication, but if it ever does in the future, it would use that same shared login across the platforms. So well, we're going to talk about NAN. NAN is mostly about instrumentation and data collection. NMR-Box is mostly about data processing and analysis. And BMRB is about deposition of the NMR information into the public domain. And everything is under the hub, under the umbrella of NMRhub now, as Jeff pointed out. So I'm going to do a few slides kind of outlining what NMR-Box is, and I'll be bouncing back and forth. I'm going to try to do as much of this as a live demonstration as I can. But we'll see how that goes. So NMR-Box was really motivated for years ago, but by different ways. But Jeff and I would go around presenting how to do advanced NMR data processing for years and years now. And generally, whenever we would go somewhere, we'd spend the first half a day doing nothing more than getting people's computer systems up and running, where they can actually use the various software packages needed for the demonstrations or the tutorials. So that led us down the path to using virtual machines, and which led us to NMR-Box. But I think NMR-Box solves a lot of problems. It's with NMR software and scientific software in general, a discovery problem, because there's so many different NMR software packages and other scientific software packages. It's kind of hard to discover them. So by aggregating NMR software into one location, we can help with the discovery process. Fragmentation of operating systems libraries, keeping NMR software that was developed in the 90s alive and running in the 2020s is not a trivial task. And a lot of good software may be very difficult to be ported moving forward. Persistency of the software, sometimes the software can't even be downloaded anymore. So we're acting as sort of a clearinghouse for software. Complexity, there are various software packages that rely on many other software packages, all being installed and configured in a way that they all can interact with one another. King is shown here as an example that requires a lot of software packages, many of them very old and difficult to maintain. And then one is for reproducibility. So the ability to be able to rerun software for any given version into the future. I'll just start off with a little bit of NMR-Box by the numbers and then get into what NMR-Box is. So currently we have over 5,000 registered users of the NMR-Box platform. On average, we get about 2 new users per day. Generally speaking, about half of them are from the US, half of them are from other parts of the world. We have 77 countries represented by our user base, and we have all users from all 50 US states. We have currently 261 software packages on our platform. I haven't looked recently, but billions upon billions of program executions. Some of our more popular software is listed here. NMR Pipes has over 1,200 unique users that have run 385 million NMR pipe instances. Mestranova, over 300 users who have used it 16,000 times. CCP NMR analysis and Sparky are very popular with well over 1,000 users and been run a couple 100,000 times. We also do a lot of community outreach. We've hosted over 100 community events. We receive about 600 support tickets per year that we try to answer to the best of our ability, and then we have videos, lectures, tutorials. In any given moment, we have about 500 unique users connected to our system. So the NMR box is a place where you can do NMR data processing and analysis. We have roughly 260 software packages. We are agnostic to software packages. We will install whatever the community wants us to install, and we are able to. We have to vet the software to make sure that we have the rights to put it on our platform. But if we do, we will try to put it on. Most of the software packages that we install today are by the community request. Our platform is based on Ubuntu, the version 20.04, and we actually use a flavor of Ubuntu called Xubuntu because it works very well with VNC connections, which we'll see in a moment. For NMR software, we put in all flavors from spectral reconstruction to visualization, peak picking, spin simulation, basically everything that relates to NMR, we're willing to install onto the platform. In addition to NMR software, we also have packages from SACS, cryo-EM, electrodynamics, bioinformatics tools, of course, molecular visualization tools, because we know researchers don't just do NMR, they do projects that span out for these other biophysical techniques as well. We have a few commercial packages installed. We have MATLAB installed, including all toolboxes. We have a Mestranova site license, so we can present Mestranova. Topspin, OpenVNMRJ is not really commercial anymore, but we do have OpenVNMRJ installed in a data cord from Bruce Johnson's lab. We try to make the package be as friendly to people as possible. In doing so, we have lots of various editors, office tools, drawing tools. We try to install as many Python libraries globally for people as possible. And we have a full complement of development library. So hopefully people could, if they need to compile software on the platform, they'll be able to. If not, we can always assist with that by spinning up a dedicated server for somebody to log in and do development work if needed. So you just need to contact us if that's the case. All our software is persistent. We archive all the software as it's downloaded. We install it and we package things in a way that makes it easy to provision into the NMR box platforms, and all of that is persistent and backed up. And we archive all the versions, not every version of NMR box. I'll talk more about that in a moment when we get to this slide here, which is our release schedule. So what we do for our releases now is we have a rolling release model, and we've broken our servers into 6 groups. And 1/6, one group gets refreshed every 2 weeks. The version numbers are just the year and then the week. And that means each VM, each production host will have a 12-week lifespan. And then once per 12-week lifespan, we call it a long-term support version, and that's a version that we will archive and keep alive into the future. The advantage of this rolling release model is we don't need to do a complete shutdown of the platform in order to do an upgrade. We also can get timely new and updated software installations put out there. It helps us with hardware updates. If a server needs to be have service done to it, it's fine, you know, because we could just wait for its cycle to come up. We could take it offline and then bring it back online when we need. And then long calculations can be started at any time. So a user can choose to decide to do a calculation on a machine that has a long time to live. And I'll show more about that in just a moment. There is one disadvantage to doing this rolling release model, and that is that we have heterogeneity of software versions across the VMs. And I'm going to talk more about that a little bit later as well. So behind the scenes, we have a lot of users, and we need a lot of computational horsepower to satisfy the user demand. Currently, we have 66 physical servers in our cluster with roughly 5,000 CPU cores, 34 terabytes of RAM, a lot of GPUs, including NVIDIA A100s and H100s, comprising over 300,000 CUDA cores. So we have between the CPUs and GPUs, we now have over a petaflop of compute power capability. We have a fairly substantial amount of storage. We have a couple petabytes of nearline network storage for NAND and NMR box. We also have 150 terabytes of local NVMe storage on the production host themselves, and I'll talk more about that a little bit later as well. And then, and we also have access to a university resource with even more storage for archival purposes. We run out of a data center with significant capabilities as far as UPS power, dedicated generator, 100 gig pipe to the internet, lots of cooling, and very capable network. And in the future, we actually have a hardware supplement. Is no longer pending. We have a hardware budget for the next few years to add to the resources in about 500,000 K range. So we will be expanding resources in the next few years as well. To gain access to NMR box, it's free. Now, I should say that it is free for academic institutions, government institutions, and nonprofits. NMR box currently is not available for for-profit organizations. We offer two ways of accessing NMR box. One is we call platform as a service. This is when you log in and you use our servers. And the other way to do is to download the VM and run it locally. The downloadable VM is not something that we prioritize, nor is it something that the user community uses very much. So we put most of our resources into developing the platform itself. We allow logins with a full graphical user interface, which you'll see in a moment. SSH connections. You can run it anywhere. Your jobs are persistent. Advantage is that you could be utilizing high core, high memory production hosts. If you need to do 3D rendering, say with PyMol, it is backed by GPU, so you do get good performance. We have a lot of GPU processing capability, so you can do CUDA processing. And we try our best to make sure that your data is protected by using enterprise class devices to store your data and to maintain it. As I said, there's two ways to connect to NMR box. One is SSH and one is VNC. So SSH is probably familiar to most people. You just can use SSH and you'll get terminal access. You can use that to do data transfers, of course, and we support X11 forwarding. So if you're on another system that's running X11, such as a Mac or another Linux computer, you can run graphical interfaces through SSH. But the vast majority of people who connect NMR box connect with VNC. We use a commercial product called Real VNC. So we pay for the VNC server on our end that provide some very nice features that the free versions of VNC don't. But the viewer portion that the user needs to connect to, that is free. So the viewer is actually free to download. And it can be downloaded on any device: Windows, Macs, Linux, Android, OS X, iOS, and it works on virtually any device. Some nice advantages to VNC, or the commercial version of VNC that we utilize on the server side, is that you do automatic connections. There's single sign-on. Your NMR box account is the same account and password for connecting via VNC. Your sessions remain persistent even when you terminate the viewer. Everything is fully encrypted. So if you did pass a password in on a website or whatever, the data connection is fully encrypted. We've created a dynamic resolution changer. If you have a local printer on your local computer, that gets mapped to the virtual to the session. So you can be printing something even though you're on our servers, it will come out on your own printer. You can share sessions, and now there's even support for sound, which is nice. If you're watching, say, a video tutorial inside an NMR box, you can get sound now. So we provide a lot of services, and a lot of the services we provide are through the NMR box website. So I'm going to jump over to the NMR box website and show you what it looks like. So when you come to the NMR box website, which is just if you type nmrbox.org, you'll land here. And you'll come up on a splash screen, just sort of typical for most websites. We have some information about high level information about NMR box. But we have a very tabs that have come across here with some useful features. So one very useful feature is the hardware page. So when you come to the hardware page, you'll see a list of all of our servers that are running. And most of our servers are named after elements in the periodic table. We have a few that are named after scientists. And we have different classes of production hosts. So most users are going to see all of these NMR box VMs are shown to everybody who has an account. We have 3 very highly capable machines that we call the machine learning VMs. These you can gain access to, but only through a request from us. But if you have access to them, these would show up. I see one additional one because I am at UConn, so we have one special server that's dedicated only to people here at UConn. You can see the various pieces of information. So we have a status window. So most of these are good, but we can actually see that we have a couple servers that are having some issues currently. So if you try to log into a server and you're not connecting, this is a good place to come and look, because there may be a notification as to why that would be the case. This tells us which servers I am connected to. So there's a server called Gauss. I have a little screen here that tells me that I am currently connected to that particular host. Days, as I said, we do a rolling release cycle. So that means each production host has a certain number of days before it's going to be rebooted. And right now it's sorted based on the length of time. So you can see these servers here only have 11 days till they're going to be rebooted. So if you knew you were starting a job that was going to take 3 weeks, this wouldn't be the place to do it. You'd want to come and start that on one of the servers that's going to have a long time to live. We're also showing the number of CPUs, the amount of RAM, the number and type of GPU, And then currently we're also showing you the GPU load, the GPU memory usage, and the CPU usage. And if you click this little gear here, you can essentially turn on and off various, you can turn on and off various things. So I turned on the number of users, just tells us the number of users who are currently connected to the host themselves, for instance. So back up to the top, we can see under software. So software gives us a list of all the NMR software packages that we have installed, which is quite numerous. We do have some search capability. So at the top, you can type search. So if I do a search for, say, NMR pipe, and I say, well, show me everything that contains NMR pipe, we can see that we have 16 packages that reference NMR pipe. They're not all NMR pipe, of course, only one of them is, but these have NMR pipe somewhere in their descriptions. But we do have a package, say, NMR pipe, we can look at. So we can open that package here. And when we open it, we can see several things. One, we can see all the software versions of NMR pipe that we've ever installed. And Frank does a great job of keeping NMR pipe up to date for the user community. So we have a lot of different software versions. If you have a particular version and you want to know where it can be run from, you can hit the view available VMs. And this just brings us back to that hardware page we just saw, but we have a filter. So it's showing us only the production hosts that have that particular version running on it. We can also see information about usage statistics. So we can see that the number of users for unique users for NMR pipe are 1,195. We can see the total number of runs that have occurred. We can click on citation information. If you used NMR pipe in your processing or in your study and you're publishing a paper, we have information for how to reference the software that you're utilizing. We also have this button here that says view talks referencing the software package. So we can come in and we can click on this and we can see all of these talks that use and that have NMR pipe in them. And we just pick one arbitrary. This happened to be from our workshop in 2019. And you can see here, it was from the NMR Box Summer Workshop of 2019. The speaker for this particular session was Frank and myself. There are 5 different software packages were listed that were used in this talk. I'm not going to click it here, but you can click this video file which actually starts showing you a video of the presentation that Frank and I gave that day, some PDF documentation that goes with this presentation, and there's a PowerPoint presentation, which I believe is Frank Delaglio's PowerPoint presentation that he used in the talk. So we have lots of information. You can link over to that summer workshop itself. So now we're actually in an event view instead of a talk view, and we can see all the talks that were given during the NMR Box summer workshop with videos and documentation and who gave the presentation. We can also search things by speakers. So maybe you're wondering, well, has somebody, a particular person ever given a talk? You can put their name in and you can click related talks, and then you can see the various presentations that person may have given in documentation that goes with it. So those are all that we basically just got through just by looking at a software package. So on the community page, we can get to, so now we're at the community tab, and we have various pieces of information that could be seen in red. I'm not going to click through most of them, or any of them actually, but I am going to point out the NMR Box Slack channel. If you click here, it will give information for how to join our community Slack channel. Our community Slack channel is a place where we're providing more and more information for people to connect to us. and to ask questions about the status of NMR box, put a request in for support. It could be a support question or whatever. It's just a good way for the community to interact with us. We can click a map that will show you where our user base is and how many users we have in different parts of the world. And under publications, we have a list of publications that our user base has used, have published that have used NMR box. And we encourage people to let us know if there are others. The events page I'm mostly going to skip because we just went through that, like by getting there through other ways. And another thing is a support. So if we go to the support page, we have FAQs. So we do encourage people, if they're having issues, to come look at the FAQs, because often the answer to the problem you have may have been already documented. And under documentation, in particular, there's a getting started guide. This is something that's sent to you when you join NMR box, but it's nice to potentially come back and look at it as we add features. This getting started guide can be updated. So that largely takes us through the website. The last thing I'm going to show is there's this My Account. And from the My Account, we can do the VM dashboard. That's just the list of all our production hosts. You can also do groups. And what groups do, it allows you to create a collaboration group and invite users. And those collaboration groups are then show up inside NMR box as a shared folder. So this is a way where if you're working with multiple people, you can all join the same shared folder and you can share files with one another. And it's fairly easy to just create a new group and to add and manage the users that are in your group from here. We also offer a tool called software usage that shows you the NMR software packages that you've used on NMR box, and it allows you to simply select a couple of them if you're publishing a paper. And I'm not going to click it here, but if you can download a bib file, and then you can import that into your reference manager for your publication. So I think we have a lot of nice features on the website. And now what I want to do is I'm going to go over to NMR box itself and give you a quick tour of NMR box. So most people connect to NMR box with VNC. There's a couple ways you can get in. So the way I normally do it is to open up the VNC viewer window itself, and then I can type in a computer name. So I'm just going to say I'm going to connect to Cobalt. You have to put your NMR box username in, of course. I'm just going to say remember for right now. And NMR box will open. So we are now connected to our remote server with a full graphical interface. And it's like you've just connected into your own sort of Linux computer. And I want to just point out a few of the things that we can do inside the VM itself. One is we have this little NMR box icon, and I'll discuss each of these in particular. One is we have a help desk, which if you're ever having a problem inside NMR box, a problem with a software package not working right, and you're in NMR box, you can just spawn your own ticket. So you can type the subject and the message, you hit submit. And that just spawned a support ticket into our system. So all the NMR box developers actually just got an email notification. So this is a great way when you're having a problem to use that support system. The nice thing about this too is it also tells us like which production host you were on. And if you do have to put support tickets in, we do ask you put as much information as you can. We got lots of support tickets that says NMR box isn't working, but it's helpful to have a little bit more information than that to try to diagnose what the problem is. So I want to point out, very typical of Windows computers, you come and there's going to be a software listing, and we don't have like a listing of all the software, like from a launcher window, like you typically would see, say, on a Windows computer. The reason for that is the NMR software comes in lots of different flavors. Some of them come with that are just a single graphical user interface program, which would be nice to have an icon there to launch the program. But then a lot of others are just, they might be a Python library, or they might have to be run from a terminal. And we found when we had launchers for the appropriate programs that the user base thought that those were the only software that we had installed. So we wanted to make sure everybody knew about all of our software. So we've, to do that, we took away the launchers and we created a software explorer. So this just lists all the same software packages that we saw on the website. You can then search for a particular package. Let's say you are looking for Kara, and it will tell you in order to run Kara, you need to type either Kara all caps or Kara lower caps. And it gives you the same information that you would have seen on the NMR Box website. And there's a link to the NMR Box website itself. So the Software Explorer could be a very good way to gain access to see what software is on NMR Box, in addition to the NMR Box website. So some other features of NMR Box we have a screen resolution changer. So right now you can see NMR Box isn't filling my screen. If I have a larger screen, I might want to enlarge that screen so I can choose a more appropriate screen resolution. You see it just dynamically changes. Anything that was running would remain running. We allow things to be added to the favorites. So you could save this to your favorites. If I go to my favorites, I can see I have a couple resolutions that I can toggle between. This is nice if you work on a couple different computer systems. You can just have quick launches. You can also save a given setting to a startup file. And so next time you launch NMR Box, it will default to that screen resolution. So very important to use the screen resolution changer to get the most out of NMR Box. And the last thing I'll point out are messages. Right now I have no messages, but if there were messages that we wanted to pass to you, you would see those messages appear right here. So as I said earlier, your sessions are persistent. So right now, if this session is running, and I'm running Mestranova, for instance, and if I go over to the NMR Box website, and I go to hardware, if it's working correctly, I should have, and I don't see it. Do I need to refresh? Yeah. So I needed to do a screen refresh, but it shows me now that Cobalt is I'm actually logged into Cobalt. And if I kind of take NMR Box, and so sometimes I might have a problem and NMR Box may be stuck. Actually, I'm going to change the resolution down very quickly to something smaller. So NMR Box is running, but it's kind of a smaller screen right now. And maybe this NMR Box session was hung and I couldn't do anything with it anymore. I can actually just come right in here and I can hit terminate, and you'll notice that the session died. So that is a nice way to get out of sessions that are froze. So if you ever have a session that's froze, you can go to the website and just kill it yourself. And if that doesn't have work, you can always, of course, enter a support ticket. What I'm looking for. If I go back into NMR Box, and you'll notice now this time it started full screen because I changed my preference last time I was in. So the last thing I want to show you on NMR box is kind of where things live. So it's important to kind of know where various files are inside NMR box. So one, there's a home folder. So everybody has a home folder under home, NMR box, and then your username. Some users may have a number in between NMR box and Micheski. It's because we have too many users. We didn't want them all in one directory. So we started putting into subdirectories. Under all the software that we install on NMR box, we install into user software. We go to user software, and we can see a very long list of all of the software packages that we have installed. And it's important to know this because sometimes when we install software, we install all the files that the developer of that software provide, including very often documentation. So if I go into, say, the Relax package and go to the docs package, there is the Relax PDF, which is the user manual for the Relax software. This is also going to be true for tutorial data, example data. So it's always good to, when you're using a software package, to be able to get into there and to see what is there. And sometimes we'll create our own files right in the directory of the software itself with information about the packages themselves. Maybe some idiosyncrasies of how that package is going to work on the NMR box platform that we're can convey to the users. We also have a public folder. So if you need to share a file with a bunch of people, or you just have a one-off, you want to share a single file, but you don't want to create a collaboration group to do it, you can just drop that file or create a directory in the public folder itself. If you do make collaboration groups, as I showed you on the website, that'll show up right here in public groups. And you see, I don't have access to most of these groups because I don't belong to them. But if I found one where I did, say my own, then I could go in and read them. In addition, we have at the highest level, we have a folder called Repository. And we have a folder called Repository, if I can click in it again. And Repository is a directory that's on NMR box that has file-based databases that the NMR box community utilizes quite a bit. So we have the entire content of the protein data bank, the BMRB, the Gizmo database, the AlphaFold database, at least one or two of the NCBI databases. So if you're doing a study and you need access to these databases, you don't need to download them. And furthermore, we're versioning controlling these databases in their persistence. So the old versions remain on the system. So if you're doing like a computational study and you want to lock your study to use a particular version of the PDB, that Repository is a good place to be able to do that. And then the last directory I want to show you is the Scratch directory. And the Scratch directory, everybody, whatever your home folder is that not working? Oh, because I have a typo. Well, I'm not going to go into it, but everybody has a folder. It's /scratch, and then whatever your home folder is. And the advantage of the Scratch directory is that it is a local drive. So your home NMR box home folders are on a remote file system. So it doesn't matter which NMR box host you connect to, your files will all look the same. But the downside of that is performance could be slow at times. So if you have something that reads and writes like thousands and thousands of times to files inside your home folder, you can have performance issues. So that's not the underlying storage system itself. It's just the NFS mount point technology that's used that has like a lag to it. But in order to circumvent that, you can process data on the scratch disk, and the scratch disk is a local NVMe on that production host itself. So you get very, very high performance. So if your jobs are running slow and you know it's an IO problem, utilizing the scratch directory could be very helpful. So I'm going to jump back over to my PowerPoint presentation. So that's what I wanted to show about the. Oh, I guess I have a couple more slides. I'm running a little long here, so I'm going to go a little quick. File transfers. So in order to utilize NMR Box, of course, you need to get files from wherever you're using them onto the NMR Box platform. Secure copy and SFTP are common ways of doing so. Here's very common programs for accomplishing that. We also run a Globus NMR Box endpoint. If you're not familiar with Globus is, it's a cool tool. I would basically just recommend you go out and maybe read a little bit about it, but you create a Globus account. And if you're at a university, there's a very good chance that your university's account will actually work as your Globus account. And then you can create endpoints. So we've created an institutional endpoint for NMR Box, but you can create an endpoint on any computer that you have, a laptop, a work, like a lab computer. And once you have two endpoints created, you can use the Globus web interface, and you can basically do drag and drop of files between NMR Box and whatever computer you put your personal endpoint on. One of the really nice things about Globus is it circumvents firewalls. So I could be at work and move files from NMR Box to my home computer if my home computer was running an endpoint. So you get very efficient transfer of large numbers of files. You allow file syncing. The other neat thing is you don't even need to be at either endpoint. I could be at someplace else on my laptop and move a file from NMR Box to my home computer, for instance, even though I'm not sitting at either endpoint. And the transfers will restart if they get interrupted. So you don't, they'll continue. So it's a really nice feature. It's what I tell people all the time is if you want to move a couple files, don't use Globus. It's like bringing a sledgehammer out to put in a single nail. But if you want to move a large number of files, Globus could be a great tool. We also support fuse file systems. So for those who are a little bit more technically savvy, you can create a fuse file system, and then you can create your basically a local folder of your NMR Box home folder on your local Mac or your local Windows computer, and then you can just drag and drop from your local computer right into NMR Box. HD Condor. So on NMR Box, as you can imagine, with 5,000 users and 500 being connected at any one time, that sometimes resources can be limited, especially as more and more people are using NMR Box to do very heavy computational jobs. So we're asking people, we've had HD Condor for a while. And what HD Condor is a workload management system to distribute jobs. So it's a job queuing system. So if you're going to run a computationally intensive job, you can actually send that job through HD Condor. And what HD Condor will do is it will take that job, it will look for across all the NMR Box resources, find an appropriate place for it to run, and it will send a job to that location to run. It has a lot of nice features, such as checkpointing. So if you're doing a long calculation, it's going to take weeks. You can actually put in checkpointing for, like, say, every hour. So if something happens to that calculation, it terminates, you can just restart it right from one of those checkpoints. So a lot of very nice features, and it's great when you're trying to do embarrassingly parallel jobs, because in addition to just going to a single computer, you could distribute across multiple NMR production hosts. So we are at a point with NMR Box where our systems are often becoming constrained resource-wise. So we're trying to encourage the user base to use HD Condor more, and we have some carrots. So the carrots are we're offering additional computational resources, and then just some of the nice features that you get from HD Condor, like checkpointing. We're also currently sending AlphaFold jobs out to the Open Science Grid if they're submitted through HD Condor. So if our resources become limited for AlphaFold runs, those will get spawned out to the Open Science Grid. So really gaining a lot of additional computational resources. And we have a couple sticks that we're about to roll out. One of them is we're just going to limit the number of SSH and screen connections a user can do. We're not going to just let you connect into 40 servers at once via SSH to run your distributed jobs. And the other thing we're doing is we're starting to migrate more of our resources into running only HD Condor jobs. So the number of servers you'll be able to log into graphically is going to decline, and but the number of servers that are supporting the HD Condor pool are going to grow. And we have a really nice tutorial for how to get to use NMR HD Condor on NMR Box. This is just basically showing some of our resources, how we're going to be pulling some of our compute resources over to be dedicated more to HD Condor and not allow direct logins. The last thing I want to talk about in NMR Box, and again, I'm running very late here, I'm sorry, is containers. Containers give you the ability to take an application and put it into a container where that application, including all the libraries and binaries needed to run that application, are completely isolated from the rest of the system. And we utilize Singularity containers, and we have a number of software packages on our NMR Box that are actually already running in containers, and because it's just easier for us to do that way. So that there's a lot of advantages to containers. One is, as I said, you get complete isolation of the application. The entire application, including all the files and everything that are inside that application, actually reside on the host computer as a single file, and that file is immutable. They'll run on any modern version of Linux. Once you're running them, there are some nice features from our perspective is there's no privilege escalation, so they're safe for us to run in a multi-user environment. Things like GPUs, if they're on the system, will just work. You don't need to do anything special inside the container to get them to work. And there's a lot of flexible interaction with containers. You can shell into the container. The container can be executed directly to perform some task when it gets executed. And you can even pass arbitrary commands into the container. The one real disadvantage to a container is that the user interaction with the program may change. So if I have an application that whole application is a single GUI program, well, that's easy for me to containerize because I can put it in a container and I can tell the container that when you run that one GUI program. So that program will just run and launch, and a user wouldn't even know that the program launched out of a container or not. But other programs, say NMR Pipe, which has hundreds of different binaries and shell scripts, it would be very, very difficult to containerize NMR Pipe without changing the user behavior. Now, what you could do is create a container that says NMR Pipe in it, and then somebody can shell into the container, and then they can do everything in NMR Pipe they normally would. But there's a user behavior difference there that in order to use NMR Pipe now, you have to do first you need to go into the container, and then you can do everything you used to be able to do. But NMR box, we are starting to look into utilizing containers much more than we have in the past. And the reason for that is, one, for us, is applications that are easy to containerize, that won't change user behavior, just make our life much easier as we move on to new versions of Ubuntu, because those containers will just work on a new version of Ubuntu. We don't need to rebuild the package, the installation packages, just because we have a new version of the operating system. From the user perspective, because we do rolling releases and we have heterogeneity of our software versions, this could be very inconvenient if you want to, say, distribute a job across multiple NMR box hosts with HD Condor, when different hosts have different versions of software. So we're planning on building a tool for users to create their own containers, where they can build a container of a particular version of software, or they can build a container that has a variety, a handful of software packages that are then locked for, say, a workflow. And then when you run your workflow, it doesn't even matter which production server you run on anymore, because everything will run out of that container where you've put all the software necessary for that particular workflow. Okay. I want to shift gears quickly and put a couple slides up about this other software resource that we have started. It's called NAN, or Network of Advanced NMR. And as Jeff pointed out, this is a collaboration of 3 sites: the University of Georgia, the University of Madison, and here at UConn. And it's the 3 NMR facilities there. And this mission statement for NAN is to democratize the application of high field NMR applications in biomedicine, material science, and chemistry. And here's a list of some of the deliverables that we're trying to accomplish with NAN. And NAN is a couple years old now, so we're starting to build it out, but it is not quite complete. But I'll show you where we're at currently. One big deliverable is to purchase and install 2 open access 1.1 gigahertz NMR spectrometers, a solution instrument in Georgia, and a solids instrument in Wisconsin. And I think within the year, hopefully those will be up and running and start to become available for the community to access and utilize. We're also creating a virtual facility. So we've taken the majority of the instruments at the initial 3 institutions, and we've created a virtual facility, which I'll kind of show you in a moment as a demo. And so this is going to be good for resource discovery. So somebody can come and they can see all these different instruments at all these different facilities, and especially somebody who's not a hardcore NMR person, maybe somebody wants looking to do NMR, but their institution may not have the NMR resources themselves. So, and when I want to point out though that when you add an instrument in the NAN, that doesn't mean that you're relinquishing the control of that instrument in any way to NAN. It's still the institution's instrument, and they can still allow external users to use it like they always have. It just kind of makes it available for visualization. And then the plan is, once the NAN construction phase is over, we'll add additional facilities. We're also going to provide something called knowledge bases, which I'll talk about in a moment. And we also are going to create, or we've created already, we are refining a data transport system. This will a system that will harvest experiments as they complete on NMR spectrometers, and then a web portal that is the access point to the resource discovery, data management, data access, and a virtual network operation center. The KBs I wanted to go into a little bit. So the KBs are designed to assist novice and expert users to help them, one, to determine if NMR is suitable for the research problem. This would mostly be true for a more novice user. But then also to provide resources, including interactive protocols, pulse sequences and sample schedules, processing and analysis scripts, example data sets, tutorials, and videos. Essentially everything that's needed to perform a workflow of collecting NMR data and processing and analyzing it. And the KBs are covering everything from sample preparation to setting up and running the experiment to processing and analyzing it. And initially, we were creating 4 knowledge base areas, 2 in solid state for structural biology and material science, and 2 solution state for structural biology and metabolomics. The data transport system is kind of an overview of it here. As I said, the data transport system will harvest experiments on the spectrometers. Currently, we're supporting VNMRJ and topspin. And the system works by having a daemon and a very lightweight GUI that sits on the spectrometers themselves. And then in each NMR facility, there is a gateway computer, which is just a small little computer that runs a small little lightweight program. And as experiments get completed, the daemon recognizes when experiments start and end. It then packages up those experiments and sends them over to the gateway. And from the gateway, it sends them over to our data center where they land in a receiver. They run through a data parser, which then copies them to their appropriate locations and also sends the data into the NAN database. So we have all the information about the experiments themselves. This is what the little lightweight GUI looks like. It just gives you some information about the status of the system, and it allows the user to go in and enter various extra data, say notes, for instance, and we'll talk a little bit more about some of this in a bit. But one of the important things for the data transport system is we're collecting an experiment, but we're not just getting the experiment. So what we're also getting are all the files for that experiment. So that'll be all the files that the spectrometer software is saving, but we'll also crawl the file system and go out and find all the files necessary to be able to repeat that experiment again. So then obviously we're getting all the experiment parameters, and those are all being stored into the database. Users can enter additional parameters, tags, and notes that get linked with the experiment. As we parse the data, we normalize some of the parameters for easier searching across different types of vendors. We also have information, what facility, what instrument, what probe was used to collect that experiment, who the local and NAN user was. We're providing a system to put in information about the sample, and then we're going to allow organization of the data into project studies and funding sources. So we're going to have a lot of rich metadata that goes with that, those experiments. And if I do a quick tour of the NAN website, so if you come into the NAN website, I'm going to start at facilities. So this is a work in progress. It is a live website that people are using, but it is something that is undergoing updates every 4 weeks, and we're in the midst of rolling out a lot of features. Just that little caveat that not everything is working perfect at this moment, but this is where we're at in the development cycle. So for facilities, you can see that we currently have 3 facilities, and you can obviously click on a facility and you can get more information about that particular facility. You can go to instruments, and then you can see all the instruments that are currently joined into the system. And they're color coded by what instrument you're there. Right now, we don't have very many instruments. So we don't need a lot of filtering, but if NAN can expand into multiple facilities, the filters will become very important. So somebody can say, I need to do solution state and I need a cryo probe. And it would be nice if I had a sample changer available. And then you're like, well, I need a particular type of sample changer. So you can come and you can say, well, I need a 96 tube rack system. And And whatever other filter you would need. Maybe you need a Neo console. And then you can see, well, there's only one instrument that satisfies your need. Again, right now with a limited number of instruments, things like advanced filters and search aren't as necessary, but hopefully when NAN grows, it will become more important. I'm a facility manager. So a facility manager will have the ability to enter the facility information about spectrometers and probes. Most users wouldn't see this unless you were a facility manager, just wouldn't even be present for you. Eventually, we'll have an operations dashboard. We have a nice looking operations dashboard now. We're in the midst of integrating it into the website directly. If you're a PI, you're going to have the ability to manage the users inside your group. So you can set what permissions that different users will have inside your group. So all of this is things that are sort of rolling out. The one thing I really kind of want to show you is the data browser. So the data browser shows you all of the experiments that you've collected. Now because I'm a facility manager and an administrator on the site, I see a lot of experiments. Users, when they come in, will only see experiments that they own or they're privileged to see based on how the permissions are set. But you can see here are all the experiments that have been collected. There's 3,401 experiments that have been collected at the NMR facility here since we started harvesting data. And we can see things such as the data set name, the date that it was collected, the instrument it came from, what the pulse program was, and all sorts of various information, who the local workstation user was. And we can click and we can turn various fields on and off. So if you need to know what the temperature was, you can put the temperature on, and you can see the different fields. I'll just turn a couple of these off for now, so it fits on the screen a little better. So if you want to edit information about an experiment, you can double click in, and if there's pieces of information you would like to add, you can say add a note and hit save. You'll be able to change, you can change like who the user is. If it's the wrong user based on permissions, you'd be able to do that. You can classify experiments. So if you're in the experiment and you know maybe this was failed because the sample had a problem, so you can change the status. You can classify experiments. We're also allowing things in bulk action. So if you click on a bunch of experiments, you can do things like let's say I can classify all these as a calibration experiment. And so you can do things in bulk action. You can also download the data set from here, and you can download single data sets or you can download multiple data sets. All of these columns could be filtered. So we actually have a column called redundant, just tells us whether or not the experiment was actually run redundantly in the same job. So you can see here, these two experiments were both run in the same job. So the most recent one we're calling not redundant. Any other experiment would be redundant, but we can, let's say we don't want to see any of the redundant experiments, so we could turn that filter on. So we can filter and sort on any of these columns. And in the future, we have the ability to save filters and quick filters coming. So this is what we have, kind of where NAN is currently. And I went way too long, and I'm very sorry. But that's what I have on NMR box in NAN.
Okay, thanks, Mark. I'll jump in then and just give a brief overview of Biomag ResBank. A couple of comments though about the NMR accessibility of NMR box and NAN. Although Mark pointed out it's currently only available to not-for-profit, academic, and government users. there's a lot of interest in commercial use of NMR box, and we're actively working on trying to jump through the various hoops that are needed to be able to deploy it for commercial use and commercial access. And if you happen to be at a commercial institution or entity and are interested in NMR box, drop us a line and let us know what kind of applications are particularly appealing to you, and we can keep you posted on developments and when it might be available. NAN, as Mark mentioned, is currently just the 3 institutions, but we're currently in the NSF construction phase, and once NAN reaches the end of the construction phase, the intention is to open it up and have a call for proposals for additional NMR facilities around the U.S. That are interested in joining to make that feasible, so that they can take advantage of the NAN cyber infrastructure. With that, let me. I think Mark, you may still be sharing your screen.
Oh, sorry.
Okay. Are we?
Yes.
We see the BMRB? Okay. Just a brief acknowledgement. There's a really fabulous team of individuals who operate the BMRB platform and acknowledge the support from the National Institutes of Health since roughly the mid-1980s. As I mentioned previously, it was founded by John Markley and Eldon Ulrich at the University of Wisconsin back in the mid-1980s. It subsequently became a core archive and member of the Worldwide Protein Data Bank. And with John Markley's retirement in 2020, BMRB moved to UConn, where it was given a new URL. BMRB.io is now where you access the resources for BMRB. I'll just mention in passing too, you may notice that there's the maroon helix that was the longtime logo for BMRB has been replaced with this green one. Another subtle difference the structural biologists will appreciate is that the helix is now a right-handed helix as opposed to the left-handed helix of the old BMRB logo. Just a quick overview of the content of BMRB. Our bread and butter has been assigned chemical shifts, and there are literally millions of them, mainly for proteins, but some nucleic acids, and quite a bit of small molecule data as well. That turns out is quite useful to the metabolomics and natural products community. There's some relaxation data, some coupling constant data, a handful merely of experimental time domain data sets. And again, as I mentioned, there's quite a bit of small molecule reference spectra in addition to assigned chemical shifts for small molecules. The new website looks something like this. It's organized around this matrix that's sort of in the center. There remains this quick search bar at the top where you can just put in arbitrary search terms. But navigating more purposely is done via this matrix. And the way it works is that the outer ring corresponds to different aspects of the website. If you click on one, what happens is that the middle panel comes up with more detailed information. And then to launch into that particular resource, you would then click on the center panel. Another thing worth pointing out is that on the bottom right of every BMRB webpage, there's a support button which will launch a ticket that allows you to get help with utilizing the BMRB website or any of the services it supports. So I'll just run quickly through some of the services. The software service include tools for parsing the NMR star format data visualization, and as well if you're doing surveys, tools for doing programmatic surveys and access to the BMRB content via an API. We also host a computing service for CS Rosetta, that's used quite extensively. It runs on a dedicated cluster at UConn Health. And for data out, you can access the BMRB data in a number of ways, either via the website or Globus, rsync, and as Mark pointed out, it's also BMRB data is contained in the Roboxitory data lake that resides on the NMR Box platform. BMRB also hosts the Gizmo database, which is a database of modeled spin systems for small molecules. It's approaching now about 1,000 biologically relevant small molecules. The nice thing about having modeled spin systems is that you can then simulate what the spectrum looks like at an arbitrary field strength, and you can simulate mixtures of compounds as well using Gizmo. In addition, we provide Python parsers again for reading and validating NMR star data. There's a visualization tool that's also available in Python. Links here. By the way, these both Mark and my presentation slides are going to be made available on the NMR Box platform, so that you'll have access to these slide decks later on if you want to do it. Access them. Just an example of data visualization. You can look at what is simulated peak positions, for example, in an N15 proton HSQC, or look at chemical shift distributions. This is just an overview of the load on the CS Rosetta web service that will predict protein folds simply from assigned chemical shifts. For data out services, again, you can get access to BMRB data in a variety of different ways, and I've gone over that a bit. But I just wanted to take a moment to get those of you still with us to think about BMRB in new ways. So, of course, the data in BMRB was very important for the development of applications like Talos, the Chemical Shift Index, Sparta, RefDB. And as powerful as those are, they were all based on kind of the consensus data that's available. The main body of the distribution of chemical shifts. The general trends. But one thing worth keeping in mind is that there's now sufficient data in the BMRB that what previously were thought of as outliers are now becoming statistically significant. And if you drill down a little more carefully, you can see that there are now, in many instances, there are hundreds of outliers. And what's interesting is that because they now have statistical weight, you can potentially mine these for new insights into structure and dynamics of biological macromolecules. So I'll give you just one example of how we've done that. Back in 1988, Levitt and Perutz hypothesized that an amide NH group could hydrogen bond to the p-pi cloud of an aromatic amino acid, and they did some quantum calculations and calculated it would have about a 3.5 kcal per mole favorable enthalpy. Oddly, they hypothesized that the hydrogen bond would point at the center of the aromatic ring. On retrospect, if it is a donation of a proton to a p-pi cloud, you would think it would be pointing to one of the ring atoms where the p-pi cloud is centered. What's interesting is that by doing a survey where we mined all the outliers in BMRB for amide protons and then searched the corresponding protein data bank files, we've identified literally hundreds of instances in the protein data bank of this kind of aromatic to amide hydrogen bond in the first instance. But number two, we also realized that when you look at the angular distributions, it was pretty clear that hydrogen bonds, as you might suspect, were not pointed at the center of the aromatic ring. They were indeed pointed to they were directly positioned above one of the ring carbons, the aromatic rings. And that work got published a couple of years ago back in magnetic resonance. You can go take a look at those findings if you're interested. But the main point I wanted to make here is to start thinking about BMRB as a source not just of general trends, but a potential wealth of information about structural biology from the outliers. The data lake got mentioned, and the significance of Roboxitory is that it can really speed up the kinds of surveys that were done, for example, in the case of the survey for aromatic amide hydrogen bonds. And that data lake can be accessed in a number of different ways. And I think with that, I'm going to one other thing I wanted to mention is that depositions to BMRB are done via the BMRB website or via the PDB OneDep deposition platform. But we also have something called BMR-Big, which we refer to as the front porch for BMRB, in that it will accept data that is not necessarily curated and doesn't necessarily have to correspond to a given data type that is curated by the BMRB team. So it can be a very useful platform for collecting the data for a future BMRB entry, for example, or if you want to upload allied data like mass spec or cryo-EM data that is connected to a BMRB deposition. And it is much simpler to use than BMRB because it doesn't go through a curation process or annotation, but it is persistent, and a digital object identifier can be assigned to data that's uploaded to BMRB, BMR-Big. And again, the URL is bmrbig.org. And finally, I'll close with a plea to those of you listening. The importance of BMRB has gained is because of depositions and the generosity of the user community. And for it to maintain relevance in the future, it needs to continue to grow, especially with additional types of NMR data. We're particularly interested in getting data on IDPs and IDRs, chemical shift perturbation studies. We'd like to collect a lot more relaxation data in RDCs, and finally, a lot more time domain data. And with that, I'll close. And I think at this point, I'll turn it back over to Dave, who I think is going to be the moderator for the remaining of the session.
Dave, you are muted.
Unmute. Okay. So actually, Jeff, you can certainly moderate questions. And so let me just get everyone started. You're encouraged now to everyone to log in, show yourself, and ask your questions. So does anyone want to start? And Jeff, why don't you take it from there?
Okay, Marcus Vollmer has posted a question. Marcus, are you here? I turn your camera on, and you can. Why don't you verbalize your question, and then we can answer it.
And if there's a silence, speak up with your question.
Fantastic. This is really a great topic and fantastic progress that you've been making, Jeff. I was wondering, what are the requirements to actually join NON, or at least the data storage section of it? Like if we would like to access and store data on your servers, how would that work? Would that even work?
So we're still formulating the full requirements, but I can give you just a brief overview of what it's going to entail. One will be that you need to invest in a dedicated gateway computer that would be co-located in your facility, and behind whatever firewalls, and ideally this would sit, in proximity to the NMR spectrometers that are connected, and then you also would have to install the lightweight client software on the various spectrometers that you want to attach. And finally, an NMR facility manager at your institution would need to manually enter facility data ranging from administrative information to information on the spectrometers, including their configuration and the probe data, so that can go into the NAND database. But that's the high-level overview.
And everybody would be able to get this process started with you guys. Everybody, like every facility would be able to do that if we fulfill all this.
So in principle, yes, we are going to have sort of a minute. We're going to have a document that a facility end user agreement that you would have that would stipulate commitments that you would have to be able to make. For example, providing the gateway computer and whatnot, and it also provides a little bit of protection for us in terms of liability. We, for example, when it comes to data security, we can only guarantee best efforts. Now, having said that, our best effort is probably better than any cloud service that you could subscribe to. It is geo-dispersed over 4 physical sites. We could have an entire building on the UConn campus blow up, and we would not lose any data. So having said that, the end user agreement stipulates that we can only guarantee best efforts.
So, yeah, I'll just chime in too. So that's all about a facility joining. I don't know if we have decisions or how. Certainly, any institution within the U.S. I don't know about institutions outside the U.S. And as far as who can access the data, one thing I didn't talk about is, I was running out of time. Many other features of NAN that are either there or are coming. One of them is the ability to publish data or make data public. So, and this is something that NIH is starting to mandate, is data become public. So data can be listed, could be owned by like the lab at which it was collected, of course. The true ownership is actually the institutions, but we're using the PIs as proxy for the institutions. But then data, like once published, could be made public. And we're going to offer a couple ways of doing that. One, you could just target data sets as public, and then anybody can log in, whether they even have an NMR box /NAN account or not, would have access to those data sets. But you'll also be able to create a group, we're calling a collection, and you can put a bunch of experiments in a collection, and then you can publish that collection, and then we'll mint the DOI. So if you're publishing a paper, for instance, you can put all the experiments used for that publication into that collection. You can publish it, and then at the time of publication, we can let that go public. And then you can even put the DOI in the publication itself, so people reading it could actually go right to the data itself.
Marcus, does that address your question?
Absolutely. Yep. Thank you so much.
Okay, great. Let's see. Truck Chief Pham has a question. Truck, are you with us? Can you? He's here. He's direct messaging me. Oh, he doesn't have a headphone. Okay. Okay. So I'll read the question. It's a very simple one. It says, will the presentations be posted and where to download them? The answer is yes. And we're going to establish a corresponding event on the NMR box events page, and you'll be able to access both my slide deck and Mark's slide deck and download it from the NMR box website. So you'll just, for example, you could just go into the NMR box events and search for Ivan, and it'll pull it up.
Actually,
in addition,
I'll go ahead. Yeah.
This is
so.
Krish.
In addition, this video will be posted on YouTube shortly by Eric.
Fantastic.
Yeah.
All Ivan panel discussions are in the YouTube channel under him, Ivan. So.
Also on the IvanMR.com website.
Yes.
Right.
So I don't know if there are any. I see Christoph is here. If there are any NMR box users with us who want to say a word about their experience, especially if there's some feedback on features they would like to see or things could work a little differently, we'd be happy to hear from you.
So we got a couple of questions, Jeff. So
okay.
the first question is, will those of us that are with industry be able to access the slides on NMR box? And I'm just, is that true?
Yes, that is true. The events page is public.
It's public, right? Okay. I couldn't remember actually. And then the other question is, will topspin ever work on NMR box again?
Take that one, Mark.
I would. The answer is certainly, hopefully. We have put a lot of time and effort into making topspin work on NMR box. The main failures with the topspin license server. It is really out of our hands. It's up to Bruker software engineers to resolve. And every once in a while, we'll try to make a push at them again to try to fix the problem. Is nothing on our end that we can control. So it's really in Bruker's hands, and we will continue to encourage them to solve the problem.
So anyone speak up with your questions?
I think it's time to wrap up, maybe.
Okay, so if there are no more questions, then we should wrap up, as Chris suggests. And I want to really thank Jeff and Mark. And Mark, your talk was not too long. It was had wonderful information in it. And so with that, if no one's going to jump in with another question, I'll declare the meeting closed.
All right.
Okay.
Okay. Thanks.
Thank you.
Bye to the
Thank you.
team.
Okay. Bye.
Of course. Thanks.